Well, how are we going to do 13?
I think, yeah, I do remember 14. I do
Yeah,
remember 14.
I do too. I do too. But
So we've done 14. I think we've done 13.
yeah, what's the best technique for doing 13?
Hello?
In other words, there's 3 techniques.
I didn't hear your question. You cut out.
They said, what is the best technique for doing 13?
Oh,
Is it the algebraic solution? Is it back solving? Or is it picking numbers along with back solving?
well,
If your life depended on it.
I would say that you would.
Die based on getting this question right or wrong, which method would you use?
I would put the numbers in.
Exactly. That's always the answer when it's a life or death question. You're going to test each number. So you test 4. If that works, that's the answer. Because these are not squares. These are ovals, which means there's only one correct answer here.
Right.
Just test them all. And when you find one that works, you got your answer.
Mm-hmm.
All right. We did do these. Because I remember doing the range, yeah.
Yeah, I do too.
Well, so let's just go through each one of these and see if we see any new problems. Number 20. Ooh, it's kind of weird.
We did that last time.
Yes, we did. I remember because I didn't pick up the word closest.
Yep.
This is the same page.
Did I send it to you twice?
I guess so. 94 and 95 were the same. And we've done 24. I don't think we did 25. I think that's where.
I think that's where we ended.
Yeah, I do too. Okay, let's do 25. Let me take a snapshot of it. They want to know this. Has a width of 5. We don't know what the perimeter is yet. I mean, we know what the perimeter is, but we don't know what the height is yet.
No.
What is that? Have to be if the perimeter is 34.
So that would be adding everything up around the outsides for the perimeter.
Correct. And we know that side's 5.
So we know it's 10, and then so it can't be 7. 10.
Take 34 minus 10.
You get 24.
Now take half of that because we got 2 different sides. We got that side and we got that side.
Which would be 12, but how can the 12 be smaller than the 5?
Very easily. Look at the drawing. Oh, excuse me. The drawing doesn't really have anything to do with anything. Hold on, let me go back a step. I didn't help with my
Did you switch sides?
I did, because most of us think of the width of a rectangle being that. And the width and the length really are immaterial. In other words, what if we had a rectangle like that? Okay.
Right, exactly.
So, okay, so I'll call that 5.
And then the rest is 12.
And then the other side has to be 5.
And then 12 and 12.
Now I know that 24 divided by 2, these each have to be 12. Okay, so I apologize. I I didn't pay any attention to which was the longer side because I don't care.
Right.
It's not important. In other
Right.
words, the diagonal is going to be based on this triangle.
Mm-hmm.
One side is 5 and the other side is 12, and I don't care what it is.
Right.
Okay, so what is x? If I have a triangle that is a 5, 12, this happens to be one of the small perfect Pythagorean triangles. The very first one you want to remember is 3, 4, 5. This is the next one. In other words, there's two that they tend to throw at you a lot. And one is the 3, 4, 5 triangle. The other is the 5, 12, 13.
Oh.
Now, let's say you didn't know what that one.
Mm-hmm.
Well, the Pythagorean theorem applies, right?
Right.
So if I make that side z, then z squared has to equal 12 squared plus 5 squared. That's 169. That's z squared. Square root of 169 is 13.
Okay.
So regardless of how you do it, you can do it the long way that takes an extra 30 seconds, or you can do it by just recognizing that when you have 5 and 12 as the short sides, the hypotenuse has to be 13.
Okay.
Okay? So this question is in there. They want to give a time break to the people that recognize a 5, 12, 13 triangle. Because if you recognize that, you instantly know that's 13. If you don't, you have to go through the Pythagorean theorem to figure out that it's 13. And that's going to take you at least an extra 30 seconds.
Right.
So recognize 3, 4, 5 triangles and 5, 12, 13 triangles. And that's probably it. They don't expect you to know the ones much beyond that.
Mm-hmm.
These are the two smallest, incidentally. This is the number one smallest, and by that I mean a right triangle that has integer values for all three sides.
Okay.
The 3, 4, 5 is the smallest one. The 5, 12, 13 is the second smallest one.
Aha.
So you want to know these two.
Yep.
All right. We've done this one. These were the early steps.
Have we finished everything then?
Well, not yet. Got to make through. No, haven't done this page.
Okay.
What's a good technique to use here?
For number 15?
Yeah.
I'm not really sure.
Well, normally this looks like it would require an algebraic solution. But in reality, pick some numbers. They're not telling us what her income was. And they're only asking about ratios. So give me an income for 2003.
10,000.
Okay. Now, if that was her income in 2003, what is her income in 2004 if it's 20% higher?
So 10% would be it would be 12,000.
Okay. Now they want to know what's the ratio for income in 2004 versus her income in 2003. Now, First of all, notice that this problem is harder because we have so many zeros in it.
Right.
So let's go back and make her income in 2003 $10.
Okay.
We don't need it to be realistic.
No.
Since they're asking about ratios, is all we need is numbers. Well,
Okay.
if her income was $10, then it's going to be $12. And then I want the ratio of 12 divided by 10. What is that?
How do you know it's 12 on top?
Well, because it's the ratio of her 2004 income to her 2003
Oh, right. Okay.
income.
Got it.
So whenever you're talking about ratios, the first thing is the numerator, second thing is the denominator.
Okay.
What is that ratio?
That one is the C, 6 to 5.
Correct. And we'd have gotten it with 12,000 to 10,000. But if you spent too much time really trying to be real world, you might have said, let's try 30,000. That's a real income. And then now 20%, I got to pull out my calculator to do that. So that's that. And then I got to figure out what 36,000 is over 30,000. And that's also 6 to 5. But we've made our numbers so big that there's a lot of math. You're going to have to pull out your calculator to do this. And my point is that you need to use real numbers. You don't need to use real life numbers. I could have said her income was $10. Even though that's completely unrealistic, it solves the problem. In other words, whatever her income was has nothing to do with this problem. They have not told her what her income was. That means we can put any number on it we want.
Right.
Put the smallest numbers so the math and the arithmetic is the quickest.
Okay.
Okay. In a problem like that. Let me get rid of that blue line. All right. All right. The very first thing I see on problem 16 is there is a variable in the problem, n.
Mm-hmm.
Every single answer has a variable, n.
Mm-hmm.
That means n is not predefined. We could make up whatever we want for n.
Aha.
And that is a perfect scenario for using pick numbers and then back solve.
Okay.
Guarantee if somebody told me my life depended on this problem, I would pick numbers and back solve. Now,
so when you say pick numbers, hold on. When you say pick numbers, you mean pick from what they give you?
No.
Okay.
No. Pick numbers means I can make up an n of whatever I want.
Okay. Just making sure.
Then you got to back solve. In other words, once you pick an n that you want, you're going to be able to figure out what the answer is. Truly.
Okay.
What's a good n to pick? Remember, you're going to have to make 4n over 5. What would be a good n to use?
I don't know, 10?
Okay, I would have used 5, but 10 is fine. So we're going to let n equal 10. You notice why I would have used 5?
Because 20 over 5 is 4?
No, because it's 4 times 5 over 5. The 5's cancel immediately. So the math is easier if you pick an n of 5. If you pick an n of 10, then you got to do 4 times 10 over 5. Now there's harder math. That becomes 8 instead of 4.
Okay.
Okay, and that might seem trivial, but that's what it's all about, is picking numbers that result in the least hardest arithmetic. So we decided to use an n of 10. With an n of 10, his take-home pay is $10 per week. Correct?
Yes.
Each week, he spends $8 of that in expenses and saves the rest. So how much does he save each week?
$2.
At those rates, how many weeks will it take him to save $500? At $2 a week.
Oh. So that would be 12 and a half.
No, take
No,
the
wait a minute.
calculator and divide 500 by 2.
Oh, 250.
Okay. So that's how many weeks it's going to take him to save $500 if he makes $10 a week.
Right.
So that's all we have to do is now go back solve this. Put in 10 for n and see which answer comes out to be 250. Does A.
B does.
B does. The problem with this technique is every now and then you might find two answers that give you the same 250 weeks. In our case, no, no, and no. So we got it.
Yep.
And I did not have to algebraically formulate it. The advantage in this picking numbers and back solving is that if you pick nice numbers, you can always easily solve for that. Notice we didn't even pick the nicest number. The number we should have picked was 5.
Right.
Okay, which means we would have taken home $4 a week, and we would have saved wow, actually 10 might have been the best number we could. No, you're right. I would have picked 5 merely because I can cross those off immediately and I'm dealing with smaller numbers. But now 4/5 of 4, not so easy. Whereas when you picked an n of 10, then he makes $8 per week. Ooh, did I do that right? 4/5 of $8 is what he spends. Oh, excuse me, he takes home $10. It would have worked fine if I'd have used an n of 5. In other words, if n equals 5, then he makes $4 per week, right?
Right.
And that means he saves $1 per week. So that would have taken 500 weeks if he only made $5 a week.
Right.
Well, now I go through and check all the answers, and when n is 5, which answer gives 500? Again, only B does.
Right.
So it doesn't matter what you pick for n. You just have to pick a number for n that makes the math easy. In other words, you don't want to pick an n of 9.
No.
If I pick an n of 9, then I got to do 4 times 9 divided by 5, which is not a whole number. Introduce fractions into the whole thing. It's going to be much harder to solve. So I don't care what n I pick. I just want this to come out to be a whole number, an integer.
Right.
And I get that with an n of 5, I get it with an n of 10, I get it with an n of 15. All of
Right.
which we could figure out how many weeks.
Mm-hmm.
And then just check which one matches that answer. And this is why I call this is pick numbers and back solve. And that's always the case when you pick numbers, is you always have to continue to back solve. In other words, once you pick an n, then you figure it out, the answer based on the n you picked, and then you figure out which answer gives you that answer. So it's a two-step process. It's picking a convenient number for n, and then it's figuring out the answer, and then it's figuring out which of these 5 values equals that answer.
Right.
Now, should you use that technique and you come across a problem that gives you 2 correct answers? Very simple solution. Go back, pick a different value for n, repeat, and only decide between those 2 solutions.
Okay.
In other words, if we happen to pick an n, came up with an answer and it turned out that B was that and also E, well, I go back and pick a different n and then merely check those 2. I wouldn't have to check all 5. I know that that one couldn't be, that one couldn't be, and that one couldn't be. So the second time through with a different n, then I only have to check between these 2 to figure out which one is correct. Okay? And that will happen sometimes. In other words, it's not foolproof to pick numbers and back solve, because occasionally you will find 2 answers that both give you the correct answer. Then you kind of have to go back and start again.
Mm-hmm.
I think this,
We've done this one, I think.
that graph, this is our missing problems, isn't it?
Oh, is it?
I think so. Here, let's see if I can find that graph. I don't remember where it is. I'm going to have to go through each one of these. There we go. Got it.
That was quick.
And I was almost going to skip that one because I was so sure it wasn't this one. All right. So looking at that graph, which of the following could be the median length of unemployment in weeks for manufacturing industry who were unemployed for at least 1 week?
So where are
everybody in that diagram, is it not?
Sorry?
Isn't that everybody? There's no slice of that pie where they were not unemployed for at least 1 week. I mean, that's 1 to 4 weeks, that's 5 to 10, 11 to 14, 15 to 24, 26 weeks or more.
Well, the 1 week, at least 1 week would be the 1 to 4 weeks, right?
No, it would be everybody.
Oh, I see what you're saying, yeah.
Everybody in this pie chart has been unemployed for at least 1 week.
So what, do you just pick the biggest slice?
Well, no, hold on. Which of the following could be the median length of unemployment?
4.
It's not that simple. If I want,
It would be the one that's in the middle, right?
Yes, I want the median. So how many people have been unemployed from 1 to 4 weeks? It's 40% of 10 million.
Uh-huh.
What is it? What's 40%?
40% of 10 million would be 6 million, right?
4 million.
4 million.
40%.
Oh, right. 4 million.
All right. How many people have been unemployed from 5 to 10 weeks?
20%, so 2 million.
And from 11 to 14
will be 1 million.
1 million. I'm not sure this is going to necessarily lead me to the answer, but I'm going to do it anyway. 18% of 10 million is 1.8 million. And the last category is 26 or more. And that's 12%, so that's 1.2 million. Now, which of the following could be the median length of unemployment? Well, it's the
11 to 14?
Three, 4. I would say 5 to 10. In other words, that's in the middle. Notice there's 4 million there. And if I total these three, that's also 4 million.
I see.
So right offhand,
Well,
if I had to give a 20-second answer to this problem, I would say 5 to 10 weeks, which is that. No, that's not that. It's only that.
Yep.
And I think that's the only way we can do it. I don't think it makes sense to do it any other way.
You can kind of look at the chart and see that the section of 1 to 4 almost matches the same size of the.
You're right. So that would
11.
have to be in the middle just based on that.
Yeah.
Although median is a tricky thing,
Yeah.
notice that the median between this set of numbers is 1.
Yes.
Whereas the median between this set of numbers is 198.5. Even though the last number is 200 in both cases, and the first number is 1 in both cases, and I should have put equal amount of numbers in each case, doesn't matter. But you can see that the median is not obvious always, just from the beginning number and the last number. It really does have to do with the area. You hit it right on the head when you said that area was about equal to that area.
Yeah.
So if I had to make a guess, I would definitely guess the median is going to fall in that area there, and it does. Although I would not stake my life on it.
Yeah.
No, I wouldn't. If somebody said, would you stake your life on this answer, I would say no. Because not 100% sure I've done it correctly. I don't know how else I would do it, though. So, and I think they purposefully made that 4 million and made that 4 million. So there would be no doubt where the median occurred.
Right.
All right, let me erase my ink and let's look at 19. If one of the workers in the manufacturing and service industries who is unemployed for at least 1 week will be randomly selected, what is the probability that the person selected will be a service industry worker who was unemployed for 26 weeks or more? Wow. All right, let's figure out how many people. God, same.
So within the 26 weeks or more, you've had 12%.
Week. Why do they keep trying to trick us? That's everybody in the pie chart. Both pie charts.
Except it says who was unemployed for 26 weeks or more. So you're
We're getting to that. That'll be next. But in terms of at least 1 week, you would have thought that they would at least say at least 5 weeks to eliminate some of these. But neither question does. In other words, either question refers to everybody in the pie chart on the left and everybody in the pie chart on the right. So it's 10 million versus 8 million to start with. Okay. What's the probability that we picked from the manufacturing industry?
So it would be whatever 12% of 1.2 million.
How many total people are in both industries?
Oh, 18 million.
Okay. There's 10 million in manufacturing. They want the probability that a person was selected will be a service industry worker. So what's that going to be?
8 million.
Divided by 18. In other words, probability is the number of successes divided by the number of possibilities. Well, there's 18 million people to pick from. There's only 8 million in the service industry. So it's at least less than 50-50, correct?
Yes.
Okay, so this makes a lot of sense. 4/9. Slightly less than 50-50, and that should be the probability that we picked somebody from the service industry as opposed to the manufacturing industry. Now, given that we picked somebody from the service, we have to pick somebody from the service industry, and they have to be employed for 26 weeks or more. What should I multiply by 4/9 by?
By whatever 9% of 8 million is?
By just 0.09.
Oh.
Well, notice they're asking about probabilities. So I have just determined that the probability of picking from the service industry was 4/9. And then there's a 9% chance that if I picked from the service industry, I picked somebody who was unemployed for 26 weeks or more. So it's two numbers multiplied by one another. Well, do that on your calculator. You don't need a calculator because that's a 9 and that's a 0.09. So that's 4 divided by 100. 0.04. So if you did it on your calculator, you'd have gotten 0.04. Or you don't need a calculator. For most of these problems, you will find the calculator, even though they allow you to use it, it's not a particular advantage. This is not a hard problem. 4/9 times 0.09. All right. That may be, I don't know. I got to look at, okay, let's see. First of all, I only need one of these open, don't I? Okay, and I think we're done with questions relating to that graph. Yeah, naturally I did that.
So if that's our last, when we come to the last problems and we still have time, I have a couple questions from the exam I took.
Okay. Let me just keep searching here and see if we find anything we haven't seen yet. No, we've done that one. All right, we haven't done this one, I don't think. What is above the line say? Do you have the book in front of you by chance? I don't really need it.
I think we've done this,
I
though.
think we've done this one also. Because these quantitative comparisons are always in the beginning, not at the end.
Right.
Those are the easy questions, actually. If you ask me which are the harder questions, the easier ones for sure are the quantitative reasoning. And we've done this
Right.
also. At least that's
Done them all?
I found that I didn't find a single quantitative comparison that really presented any difficulty for me. Whereas I found all kinds of problems that presented difficulty. In other words, there's plenty of hard problems on the GRE, they're just not the quantitative. So you have a choice to do one over the other. The quantitative reasoning are the easier ones in general.
Right.
All right. Go ahead and give me the ones. You can either send a picture, or if you can verbalize them, we can do it that way.
So can I share my screen with you?
You can. I can make you the presenter if you want me to do that. It's a little cumbersome because here, I'll show you how it works. Make you the presenter. That means we're both going to be looking at your home screen.
Right.
Okay. So I'll make you the presenter.
Paint.
Yeah. Make sure you don't have anything embarrassing on your computer screen because I'm going to be looking at it here in a second. And I'm just teasing. Now you have to do something on your end to accept that.
Show my screen.
I'm trying to make you the presenter. You have to accept it.
And I did.
Okay, now I'm looking at your screen. Okay.
Okay, so they had this triangle
Mm-hmm.
on the screen, and I'm just going to draw like this.
Okay.
Whoops. Just do the straight lines, I guess. And this actually went further down.
Okay. That's why I don't use these programs.
Come on.
It takes longer to use these programs than it would be to just draw a triangle, even though it wouldn't be all there.
Okay, so
that's going to illustrate the same thing. I don't need it to be a straight line.
So they had the P, S, R as the points.
T.
I forget what the point was here.
T.
And then they had angle X.
Okay.
And angle Y.
Okay.
And they said that PS was equal to SR.
Okay.
And this was one of the quantitative reasoning ones. I had to say whether angle X was larger or angle Y was larger.
Okay.
And even though it said that these two lines were equal, I had no other information. So I picked that you couldn't tell from the information.
Well, let me have a look at that. Pretty sure that X is the same as the angle that it is next to.
You think it was a right angle?
No, I'm just saying those two angles are the same. And the reason is that that line, see, the problem with this is that I can't do anything. Let's switch it to my screen. And I'll redraw
Can you do a print? Hold on.
Is there anything else?
Do prints? Can you do a print screen and then show me?
No, but I don't need to. I can redraw this picture easy enough.
Okay.
So let's do that. I'm going to make me the presenter again. All right. So here's the triangle. right?
Yeah.
Okay. This angle right there is the same as x, because TR is a median, meaning it goes from the vertex of 1 to the middle of the opposite side, bisecting the opposite side. That only happens if you bisect that angle. So that angle is equal to that angle.
Uh-huh.
Okay. So now we have a triangle where that's 2x, and that's y. And their question is what?
Which is greater,
2x
angle X or angle Y?
is bigger, 2x or y? Well, the way I usually solve these problems is to see if I can draw it both ways. In other words, can I draw this picture where that's the bigger angle? And can I also draw it where that's the bigger angle? And if I can do both, then that means we can't tell, right?
Okay.
Okay. So I'm going to do that. That's angle X. That's angle Y. Clearly, Y is bigger than X, and all of their conditions are met.
Okay.
Right?
Yes.
Okay. Now I'm going to draw it another way. Now that's Y, and that's his X. And notice that I may not be able to tell that X is bigger than Y, but there's a whole lot of differences, right? In other words,
Yes.
in this case, Y is a huge obtuse angle, X is a real tiny acute angle. So if I really draw this thing elaborately, like that, as long as I draw a median, in other words, as long as that's the same as that, now it's really clear that X is bigger than Y.
Uh-huh.
Merely because I drew it differently.
Uh-huh.
Well, this instance, Y is bigger than X. This instance, X is bigger than Y. It's really clear that I cannot tell. And all circumstances are satisfied by the way I've drawn the median. In other words, the only thing that means is that you're drawing a median from one vertex and you're bisecting the opposite side.
Okay.
So I don't even have to know that that's X also. That was actually unnecessary. That wasn't part of the solution. If the solution involved merely trying to draw it in multiple ways, then I don't care if X is equal to X or not. Clearly that X is bigger than that Y, and clearly over here that Y is bigger than that X.
Yes.
And yet I have a median in both cases. So yeah, that you cannot tell. And a lot of times that's the only way I know how to solve some of these GRE problems, is by graphically solving them. Notice I didn't introduce the algebra. I tried. I figured out that that had to be 2x, but that didn't really help.
No.
That didn't help me solve the problem.
No.
So I decided, well, let's see if I can draw this thing differently while still maintaining all of the original premise, which is that we have a line going from T bisecting the other side. That's the only thing we know. And that's true in this picture. It's also true in this picture.
Okay.
All right.
Thank you. So then the other question that came up on the exam that I hadn't seen before was talking about the constant in an equation.
Okay.
And I didn't know what they were asking.
I need to know the problem. I can't discern what you're referring to.
Yeah, I know. Do you, well, okay, never mind
Can you
then.
take a picture real quick? Do you have it in front of you?
I do not. After I took the test, I don't have access to the problems.
Oh, right. Constants are merely not variables. I mean, I don't know if this helps you or not, but y equals mx plus b, that's the standard equation for a straight line. The
Yeah.
variables are y and x. The constants are m and b. Once you figure out what the constants are, then you still are left with your variables. In other words, that's the equation of the line. The constants are 2 and 3, not x or y. X and y, you can pick any x you want and figure out what y would be. But you can't change the 2 and you can't change the 3.
Oh, okay.
That's what makes them constants. They're not variables.
Okay. Got it.
If that helps or not. You take this test online?
Yes.
Can you send me the URL address and let me log in and we'll bring up a practice test? I mean, we only have 13 minutes, but we can do all that.
Well, what I can do is I can show you the varsity, send you the URL for the varsity tutors tests that I've taken.
Can you copy and paste it into the message window?
Yeah, let me find it first.
That's funny. I've tutored for Varsity Tutor also. Do you tutor for them also?
I do not.
I've tutored for Varsity. I've tutored for almost everybody.
Yeah.
Wise Ant, Varsity, and then there was Insta EDU for a while, and then there was tutor.com.
I did University Tutor.
I've never heard of that one. None of them pay very much. Wise Ant, I have found, is the best one in terms of getting the highest percentage. I mean, some of these are outrageous. You can work for Tutor and they pay you like $16 an hour.
I know.
No matter what, whether you're tutoring calculus or what. It's just unbelievable that they can find credible tutors.
So got the chat. There.
Okay. Let me click on that. I'm going to need a password or anything, or will this give me the problems?
This will just give you the problem.
That's perfect.
But
mainly because we don't have that much more time, so we don't need very many problems.
Do you have it? Okay.
So how would I get S? Here, let me take a picture of it so I can write on it. So they're asking, what is S sub 57?
Oh, right down there. Okay.
What's it going to be?
So it is
based on that.
I don't know. How would I do this?
Well, it's S sub 56. That's S sub n minus 1 minus 21. Now, tell me what the common difference is. This is an arithmetic sequence. It's not a geometric. It's an arithmetic, meaning every single number is separated by the same amount. What is that amount?
Is it 21?
Yes. Every number is 21 less than the previous number. If my previous number is 63, then my next number is 42. And my next number is 21. My next number is 0. and my next number is minus 21.
Okay.
So my common difference is minus 21. Okay, so
S1, would that be the beginning number of the sequence?
that's 93. Now we kind of have to go to the other equation. When you're dealing with sequences, there's actually, there's the recursive, which is this kind, where every term is based on the previous term. And then there is the standard. And the standard is a sub n of this sequence is equal to the first one times the common difference times n minus 1.
You're saying times, but you wrote add.
I meant exactly what I wrote. Sorry.
Okay.
Okay. So we figured out what the common difference is, right?
Yes.
We cannot solve for what S of 57 is based on that, because we don't know what the first term was. But then they give us the first term is 93, right, and I can now use this formula. You do memorize this formula. This is the most common formula applied to arithmetic sequences. And we're trying to solve for a sub 57. Well, it's going to be equal to a sub 1, which they're telling us is 93, plus the common difference, which we know to be minus 21, and n is 57 minus 1. So whatever that number is the answer. You have your calculator?
Hold on.
We'll do that in my head. It's got to be it's one of these three. Merely because 56 times 21. No, yeah. What's 56 times 21?
30. Wait a minute. 56 times 21? 1176.
So what's the answer?
Negative 1083.
Exactly.
Okay.
Okay. Now, this was an interesting question merely because what they give you is the recursive formula. And that only lets you get so far. The recursive formula does give you one extremely piece of information. It gives you what D is.
Okay.
In other words, to solve the problem, we got to use that formula. We can't use that formula unless we know what D is and a sub 1. Well, they give us a sub 1, and I could have called it s sub 1. In other words, there's no difference between s and a here. I could have used a in both cases. I could have used s in both cases. Usually when you're dealing with arithmetic sequences, they use a. Okay? But the recursive sequence tells you what D is. Always, it's that, minus 21. Now they give us S sub 1 as 93, and that's all I need to figure out S sub 57. Because I know that, and I know that, and I know that.
Okay.
Okay. Can I scroll down here to find another problem, or
I don't think so, but I might be able to send you another.
Yeah, see if you can put another one in that chat window, and I'll click on that. If you can copy and paste it, it shouldn't take too long.
And my computer's being slow.
Well, plus I notice this says math question of the day. How do you go back? Can you go back to yesterday and pull up their
I don't
of yesterday?
know that. Well, I might. Let's see.
In other words, I'm not sure how you're going to get another question other than doing something like that.
Oh, I've gotten. I took a test, a diagnostic test.
Mm-hmm.
I don't know if it'll show the results of my diagnostic test. Let's see if this works.
Okay, let me click on that, see what I get. I'm going to turn off this math question of the day. Don't need that anymore.
Yep, you get to see my results. Oh, you need my you need my login.
Yeah. Let's see, we only have 5 minutes. By the time I put in all that information and we look at it, we're not going to have time to solve it.
Okay.
Let me think. What else? Do you have any general questions? In other words, any general questions about formulas, about techniques? Let's just kind of review the techniques. Okay?
Yeah, I get confused with fractions when they're with negative exponents.
Okay? Tell me what this is.
So,
What number is that?
well, 2 to the third would be 8, but would that be...
No, it does not mean negative numbers. It's the biggest mistake everybody makes. They see a negative sign and they think that has to mean a negative number.
Oh, is it the
Ever a negative.
1/8?
Uh-huh. In other words, it just means reciprocal to the positive exponent.
Okay.
So if I have 3 to the minus 17th, that's 1 over 3 to the 17th.
Okay.
That's all negative exponents mean. And notice that they're never negative numbers. That's a positive number, that's a positive number. So
Right.
it's almost, you're safe if you say that they're always positive numbers. And not quite safe, because if I said minus 2 to the minus 3, that would be the same as 1 over minus 2 to the 3, and that would actually be negative 1/8. So
Right.
if you take a negative number to a negative exponent, you might get a negative answer. But that's pretty rare. I mean, in 8 years of tutoring, I would say 99% of the negative exponent problems, they use a positive base. They don't use a negative number as the base. Which means, and the reason is that everybody makes that mistake. They see a negative exponent and they want to make it a negative number. So
Right.
they don't want to help you by putting a negative base in there, which truly does make it a negative number.
Right.
Unless that was an even. If that was a 4, then that's a positive number also.
Okay.
So,
Great.
yeah. Gosh, Carolyn, I'm going to miss our work. I enjoy these GRE problems. Some of them can be very challenging.
Yeah, if I do well, then we won't need to meet again, but if I don't do so well, I'll contact you.
Despite that, I'm going to wish you well. I hope you.
Thank you very much.
I would hate to think that you paid all that money to not help your cause.
Yeah.
So I would rather you do well than not do well. And
exactly.
I hope I have been a little bit helpful.
You have been.
Well, good.
Thank you very much.
You're welcome. Carolyn, you have a good test, and hopefully, I've never said this to anybody, but hopefully I'll never talk to you again.
Yeah. Okay, thank you.
All right.
Bye.
Bye-bye.